You've seen the movies. A lone astronaut, stranded on a distant planet, survives on nothing but homegrown potatoes. But have you ever stopped to think about what that really takes? We're all familiar with the image of astronauts squeezing rehydrated food from a pouch or floating freeze-dried ice cream. It's a classic, but it's a taste of a past that just won't cut it for the future. What if I told you that the key to our survival, to becoming a truly multi-planetary species, isn't just a bigger rocket, but a single, perfectly ripe tomato? The truth is, as humanity sets its sights on Mars and a permanent return to the Moon, the critical mission isn't just getting there, it's staying there. And that means a revolution in space farming. For decades, the standard space menu has been a culinary paradox, high-tech, yet completely devoid of the one thing our bodies crave: freshness. The current system relies on what's called a food system, a logistical and nutritional marvel, but one with a ticking clock. Packaged meals, whether dehydrated, thermostabilized, or freeze-dried, lose nutritional value over time. Vitamins, especially C and K, degrade significantly after just a year or two in storage. This isn't just a minor inconvenience. It's a serious health risk. Imagine a crew on a 3-year mission to Mars. By the time they arrive, their food, their only source of sustenance, could be a nutritional wasteland. This leads to a host of problems, from weakened bones to impaired immune systems, all a direct result of the lack of fresh produce. Resupply missions are a massive undertaking, unbelievably expensive, and entirely impossible for deep space voyages. They're a logistical umbilical cord connecting astronauts to Earth, but that cord needs to be cut for us to truly explore. The reality is that for any long-duration mission, we can't just pack a pantry. We have to build a farm. This isn't about wanting a fresh salad. It's about needing it for our very survival. So how do you water a plant when the water itself floats away in a shimmering orb? Growing plants on Earth is an intuitive process. Roots go down, stems go up, and water is absorbed by a mix of gravity and capillary action. But in microgravity, all of these fundamental rules are broken. Water doesn't flow down. It clings to everything, forming blobs that can either drown the roots or never reach them at all. This is one of the single biggest challenges in space agriculture. Scientists at NASA and other space agencies had to completely rethink how a plant gets its drink. They've moved away from traditional soil and have developed ingenious solutions like plant pillows, sealed packets containing a clay-based substrate and a controlled-release fertilizer. This simple, elegant design ensures the water is delivered directly to the roots, preventing it from floating off and creating a humid, moldy mess in the cabin. The irony is that the same gravity that keeps our feet on the ground is what gives plants their sense of direction. Without it, a plant's roots and shoots can grow in all sorts of chaotic directions. The lack of a gravitational down signal means plants have to rely on other cues like light, which has made lighting systems in space habitats a critical piece of the puzzle. The technology to overcome this challenge, from specialized seed pillows to passive fluid delivery, is not only helping us on the ISS, but it's also revolutionizing hydroponic and indoor farming right here on Earth. This brings up another huge problem. What about the air they breathe? The International Space Station is an incredible feat of engineering, but it's also a testament to our ongoing dependence on Earth's atmosphere. We have systems that scrub carbon dioxide and generate oxygen, but they're complex, energy-intensive, and prone to breaking down. The true dream of space farming isn't just about providing food, it's about creating a bioregenerative life support system. The myth is that we'll just have endless supplies of oxygen tanks. The reality is that plants can act as a crucial living component of our life support. They absorb the carbon dioxide we exhale, and through photosynthesis, release the oxygen we need to breathe. They can also recycle wastewater and purify the air. Imagine a Martian outpost where the greenhouse isn't just a cafeteria, but the lungs of the entire habitat. This closed-loop system, where waste is recycled into resources, is what makes long-term settlement possible. A study on the ISS showed that even a small 10-square-meter crop can produce a significant portion of a person's daily oxygen requirements. This is a game-changer. It means every leaf of lettuce and every sprouted seed is a step towards self-sufficiency, reducing our reliance on resupply missions that are both costly and dangerous. But this beautiful symbiosis comes with its own unique set of issues. Can we really rely on delicate plants in the harsh environment of space? Beyond our atmosphere, space is a constant bath of radiation, from solar flares to galactic cosmic rays. This radiation is a huge danger to astronauts, but it's also a significant threat to space food production. The myth is that a simple greenhouse can protect the plants. The reality is that these high-energy particles can damage plant DNA, causing genetic mutations and stunting growth. It's the same type of radiation that makes a space journey a health risk for humans, and it's just as perilous for plants. Scientists are actively working on this, from developing radiation-resistant plant strains to exploring shielding materials for greenhouses. But this isn't just about a plant's survival. It's about the safety of the food itself. Will the vegetables grown in this environment be safe for human consumption? The good news is that experiments on the ISS have shown that while some genetic changes occur, the vegetables remain edible. In fact, some studies are exploring whether low doses of certain radiation could even have positive effects, a fascinating and somewhat mind-bending idea. The journey of a seed from a shielded container to a dinner plate in space is a testament to our ingenuity. But it raises another question. Can we even grow these plants on other planets? When you picture a farm on the Moon or Mars, you likely imagine astronauts digging in the dirt. But is that dirt even soil in the way we know it? The myth is that it's just like dirt back home. The reality is that lunar and Martian regolith, that's the term for the loose surface material, is a far cry from fertile soil. It's basically ground-up rock glass and mineral dust. Martian regolith, for example, is rich in iron oxides, which give it that characteristic red hue, but it's dangerously deficient in the reactive nitrogen that plants need to grow. The regolith also contains perchlorates, which are toxic to humans. So can you still grow food in it? Surprisingly, yes, but not without help. Scientists have had success growing crops like potatoes and peas in simulated lunar and Martian soil, but only after adding things like organic compost, which would need to be brought from Earth or, in the future, recycled from the crew's own waste. This process of creating a usable medium is a huge part of the space farming challenge. It's a literal process of turning rock into life, and it highlights how every single resource, even our own biological waste, must be meticulously managed and recycled for us to thrive off-world. But even with the right dirt, what about the most basic resource? Water is the lifeblood of any farm, and on long-duration space missions, it's also a crew's most critical and heaviest resource. Resupplying water is a non-starter. So how do you make a farm self-sufficient? The truth is, we have to become master recyclers. The water used to grow the plants must be recaptured and purified for reuse. This is where the closed-loop system comes back into play. The water transpired by plants is collected and added back to the system. The nutrients, too, must be recycled. Instead of constantly importing fertilizer, future space farms will need to use a form of hydroponics or aeroponics, where the nutrients are delivered directly to the roots in a closed, recirculating system. But here's a truly wild fact. Experiments have shown that a plant's sense of taste and smell is influenced by its environment. Aboard the ISS, astronauts have noted that their sense of taste is dulled, a side effect of living in microgravity. So what happens to a spicy chili pepper grown in space? Scientists wanted to find out. And guess what? Astronauts who tried them reported a surprisingly strong, peppery kick. This suggests that space food production might not just be about survival, but about providing a vital psychological boost through the pleasure of real, fresh flavor. This leads us to another key aspect of this incredible challenge. The conversation around space exploration often focuses on technology and logistics, but we frequently overlook the human element. The myth is that astronauts are all business, focused only on the mission. But the reality is that the psychological health of a crew on a multi-year mission is just as important as their physical health. The simple act of gardening, tending to something living, green and growing, has a profound positive effect. It's a connection to Earth, a sensory experience that breaks the monotony of a metallic, artificial environment. Astronauts on the ISS who have participated in plant growth experiments have spoken about the joy and relaxation it brings. They've become space gardeners, proudly showing off their crops and sharing them with their crewmates. This isn't just about a snack. It's a therapeutic activity that combats isolation and stress. The sight of a healthy, green plant is a constant, reminder of life and growth in an otherwise sterile environment. The psychological benefits of space farming may be just as vital as the nutritional ones. But how do we scale this from a small salad to a full-fledged farm? So far, most of the successful space farming experiments have focused on easy-to-grow, low-maintenance crops like lettuce, radishes, and chard. They're great for providing a fresh salad, but they're not calorie-dense enough to sustain a crew on their own. The ultimate goal is to move beyond leafy greens to a full, balanced diet. This means cultivating crops like potatoes, soybeans, and even grains. The challenges here are immense. These plants take up more space, require more energy and water, and need a longer time to grow. Imagine the sheer volume of a potato harvest needed to feed a crew for years. Scientists are looking into everything, from genetically engineering plants to have shorter stems to developing advanced cultivation systems that can automate much of the process. The dream of space agriculture is a self-sustaining habitat where astronauts can harvest, cook, and eat a diverse range of meals completely independent of Earth. This is the final and most audacious goal, to turn a barren moon or planet into a living, breathing, and feeding outpost for humanity. If you found these facts as mind-blowing as we did, be sure to subscribe and hit that bell icon so you don't miss our next video. We're constantly diving into the most incredible corners of our universe. Let us know in the comments below. What was the single most surprising fact you learned about space farming? We've seen how our journey beyond Earth isn't just about rockets and technology, but about the fundamental human need for nourishment and a connection to nature. We've gone from rehydrated pouches to the dream of a full-fledged Martian farm, overcoming challenges from gravity to radiation. The potato grown by a fictional astronaut might seem like a distant fantasy, but the science behind it is very real and happening right now. It's a testament to the fact that wherever humanity goes, we will find a way to make life flourish. What will the first fresh meal on Mars taste like? The answer to that question is being grown today.